Good day, guys. We are back to friction. We are still on our friction. What type of friction is a what? Solid friction, have right? Solid friction. On which type of solid friction? We are still on. We are now on dynamic dynamic solid friction. So we are on dynamic solid friction under friction. So what is dynamic solid friction? Can we quickly go there today? So what we mean by dynamic solid friction means friction that occur to body that is moving. What type of body that is moving? Let's have it now. When we have an horizontal body, now we are having a body like this. We are placing a particular mass here. This is a pulley system. So this is a rope, right? Another mass here. This is M1, right? This is M1. This is M2. Mass 1 is dragging mass 2. So what will happen? Mass 2 will be moving, mass 1 will be moving as well. So in this particular situation, we will be dealing with we will be dealing with the movement of mass 1 and mass 2. So let's quickly go into this. Now we have a particular thing like this, moving, pushing themselves. Do you know there will be this thing will be moving with particular acceleration? You understand? It will be moving with particular acceleration. In this horizontal body, in this dynamic friction, what we'll be only dealing with is the acceleration of this body that are moving. So we'll only be dealing with what? Acceleration. And what are the formulas for acceleration? Do you remember that force is equal to mass times acceleration? So to get our acceleration, we quickly say our acceleration is what? Force over mass. So it will be what? The force that is acting on that body divided by the mass of that body. So let's go here. Let's go. So we say acceleration here equal to what is our force? We don't know yet. What is our mass? M1 and M2, right? M1 plus M2. Do you know both of them are moving at the same time? What is the force that is acting on M1? You understand? What is the force that's acting on M1? Let's quickly go. Do you know that M2 is the one that is dragging M1? You can see M2 is dragging M1, right? If mass 2 is dragging mass 1, you know mass is not a force, right? To change it to force, we change it to what? Weight, W2, which is the same thing as what? M2 times acceleration due to gravity. Do you understand? So our W2 will be the force, mass acceleration due to gravity of M2 will be the force that is acting downwardly to drag M1, right? So the tension on this rope T, the tension T on this rope will be equal to what? W2. Wow. Do you understand? So the tension on the rope, when we're talking about tension of the rope means force that is acting on the rope. So in physics, we don't talk about force on the rope, we say tension on the rope. So that is a shortcut for you guys. So let's go. When we say weight of this mass 2 will be the one dragging this, right? Okay, now. Assuming this is a smooth surface. When I'm talking of a smooth surface, when we're talking of smooth surface, means this surface does not have friction or limited friction. So friction is not affecting this surface too much. So we will not be dealing with friction of this body. So we'll just be dealing with what? The force that is dragging this body. So what is the force that is dragging this body? W2. And when are we looking for acceleration? Acceleration is what the mass force over mass. So we quickly say W2 over M1 times M2. Or you say, do you know W2 is the same to mass acceleration due to gravity, right? Or you say our acceleration equal to M2 over M1 plus M2, everything into bracket G. When you multiply acceleration due to gravity times M2, you get W2. Do you understand? So let's quickly go there. So when we have another body here, we have another body here, when we have another body here, like this, like this, like this. So we have a mass M1 and M2, right? So this is a pulley system. There is a tension on the rope. You understand? Supplied by what? W2. You can see this is dragging this. But now this surface is rough. This is a rough surface. If this is a rough surface, definitely there will be friction acting on this body, acting on this M1. So friction is present on M1. Friction is present on M1. Wow. So there will be friction on M1. So M1, friction is disturbing this stupid M1. Ow, ow, ow. Because, this body is in contact with, this mass is in contact with the floor, right? The surface, right? And they say the surface is rough. If you have a rough surface, what will happen? There will be higher friction, which will be reducing your force. So if W2 is giving a particular force, G, If the tension on the rope is equal to W2, right? Now, there is friction on this thing, on this, what's it called? On this mass, like friction is acting on this mass, friction that will be moving in this direction. We want this thing not to go, right? So now, if there is a friction here now, what are we going to do? For us to know the force acting on this mass, how are we going to know the force? Maybe the force acting on this mass is P. You understand? Force acting on mass 1 is P1. You understand? P1 will be equal to force that is coming from W2 minus frictional force. Force that this one is supplying, or tension that is on the rope. You know, the mass 2, weight 2 is the same thing as what? Our tension. But this stupid friction is reducing some of our force that we are applying to it. So what are we going to know? The remaining force that is acting on this body. You just remove this friction from the force that this body is using to drag this one. Eléyìí on fire mass 1. Ó dẹ̀ ní friction tó ń dà láàmú. So gbogbo force tó ń supply yẹn friction máa gbà díẹ̀ díẹ̀ ń bẹ̀. Báwo ló ṣe wá mọ èyí tó ṣẹ́kù? You just minus the friction from the what? Èyí tó supply force. You will know the remaining force that is acting on this mass. So let's quickly get it. So for us to know this, we must remove it from friction. And don't forget that so what are we going to calculate? Acceleration. So acceleration, we say acceleration A equal to our what? W2 here. The same thing to be W2 minus friction. You remember that? So for you to know the force that is acting on this mass, you say W2 minus what? Friction over M1 over M1 plus M2. So W2 minus friction over M1 plus M2. So now, what is our friction? Our frictional force, if you don't forget, in our previous video, we said frictional force F equal to frictional force F. You know, coefficient of static friction is equal to what? Limiting frictional force over weight, right? Cross multiply. Your frictional force equal to what? Coefficient times what? Weight or reaction. Sometimes they use frictional force or what? Reaction. So you can say, or coefficient of frictional force times what? Or times reaction. So you understand? They are still the same thing. So now, what will be our friction? Friction will be what? Coefficient times what? Weight. Weight. Who is friction disturbing? Is it mass 1 or mass 2? It's mass 1 because mass 1 is the one that is in contact with the surface that is rough. So it will be the one that the friction is disturbing. So if friction is disturbing mass 1, which weight are we going to use here in this friction? It will be what? With 1. Do you understand? It will be what? For with 1. So you can quickly replace it here like saying that W2 minus U W1 everything all over M1 plus M2. So you can change this formula and use this. So for the second one here, the formula here is that what? Acceleration equal to W2, right? Minus W minus coefficient W1 everything over M1 plus M2. Do you get it? Or you do it like this. Acceleration equal to W M2 minus coefficient times M1 everything over M1 plus M2 all close bracket. Acceleration is gravity. When you multiply all by acceleration with gravity, what will you get? You get W2 W1. Do you understand? So this will be the formula to calculate our frictional force for horizontal surface when there is no friction and when there is friction. So let's go to inclined surface. Let's see in the next video.